In this video, we're learning how to graph linear equations. Remember, linear equations are of the form y equals mx plus b. We have 5 example equations here that we'll walk through the graphing process of. Now remember, the b term is our y-intercept. And so that means that it's where the line intercepts the y-axis. So this is at some x equals 0 value. The m value is my slope. So remember, slope is just rise over run. So that's delta y over delta x. So we can use the y-intercept as an initial point of reference and then use the slope to identify one other point. Once we have 2 points, we can draw a straight line to connect the two, and we'll have our graph. Then we can look and see if the other points of intersect match what we expect the linear equation to give us. So our slope can be written as y2 minus y1 over x2 minus x1. And so the first point would be your y-intercept, and then you can do the shift from the using your slope value, which is given, as you can see here. So let's take a look. We'll start with y equals x plus 1. And feel free to pause the video and try it on your own before comparing to our graph to see how well you match. All right, so we have y equals x plus 1. So the first thing is to identify our y-intercept. So for this case, y-intercept is equal to 1. That's what's shown here. So this will be the same as the point 0, 1. Remember, that's first value is our x component. The second value is our y component. So we go to the x equals 0 line, that's the y-axis, and make a point at y equals 1. So that'd be right here. Okay, and I have a slope. What's my slope? My slope is equal to 1 because it's basically a constant 1 times x. So y equals x plus 1 is 1, a slope of 1. So a slope of 1 would mean what? Rise. When I rise 1, the run goes up by 1. So this is equal to delta y over delta x. So I'll start at point 0, 1. I'll rise 1, so I'll go up to 0, 2, and I'll run 1. Go up to x equals 1. So that'll be my second point. And then we can repeat this process, and you'll see all of these points that I'll follow. So then I'll take a ruler, and hopefully I can line these up nicely. And I'll draw a line across. And a good way to check to see is to see if it does cross where it crosses on the x-axis. So it looks like it crosses this x-axis at x equals -1. So we can check. If x equals -1, then y would equal 0. So that checks off. So great, we got the first problem done. Let's take a look at our second problem. Our second problem is y equals -1/2 x minus 2. Okay, so the same process. We first start by identifying the y-intercept. So b is equal to -2. So I go x equals 0, y is equal to -2, and I make my first point right there. Now again, my slope here is now -1/2. So slope is equal to -1/2. So this is rise over run. Now, the negative sign tells me that I have a downward slope as opposed to the upward slope that I had in the previous example, which had a positive slope value. So if I rise in the positive direction by 1, I need to run in the -2 direction. So what does that mean? So if I rise 1, if I go up 1 vertically, then I have to run to the left 2, 1, 2. So that'd be my second point. Now I'll keep doing this. Rise 1, run 2, 1, 2. Rise 1, run 2. I could do it reverse. If I If I drop 1, then I'll run to the right, 1, 2. And so I'll grab my ruler and let's draw this line. And I'm only making multiple points so that I can try to draw a straighter line, but in reality, you only need 2 points, the y-intercept and one other point. So again, we can check, right? So this line intersects the x-axis at x equals -4. If you plug in -4 for x here, you get -1/2 times -4. That gives you 2. 2 minus 2 gives you 0, y equals 0, which matches what we have here. Okay, great. Let's take a look at our third problem, y equals 2x. So hopefully you start seeing a pattern here. So first we have to identify what our y-intercept value is. In this case, this is basically +0. So this y-intercept is 0. So where on this graph can we make our first point? Well, our first point would be x equals 0, y equals 0, the y-intercept. So that would be our origin. So I just put a dot right at the center there. And my slope is equal to 2. That's the rise over run again. So I'll rise 2 and run 2 in the same direction. So 1, 2, positive y direction. 1 for the x direction. So that'll be my first point. Rise 2, 1, 2, run 1. And the same thing. And if I drop 2, so -2 for delta y, I gotta put a -1 for delta x. 1, 2, 1, and so forth. And so we can connect these lines, or connect these points. And I should be drawing arrows at the end of these lines to identify that the line continues beyond what we've drawn here. So we could do a quick check. Let's say when x is equal to 2, y equals 2 times 2, 4. And that's what's showing here, right? 2, 4 is a point here. That's what this point represents. Great. Let's take a look where we're at. We're on our fourth problem, -3x plus 3. Okay, so what's our first step? Our first step is to identify the y-intercept. So in this case, it's 3, and we'll make a point there. So at y equals 3 on the axis. And then my slope is -3. So remember, the negative sign tells me we have a downward slope. So I'll go, let's see, I'll go up 3, 1, 2, 3, and then I'll go 1 to the left. So that'll be a point right there. Then I'll go up 3, 1, 2, 3, and then left. And I could go the opposite direction too. So I'll go down 3, 1, 2, 3. So that's a negative delta y direction. So because it's -3, I need a positive delta x component. So to the right. 1, 2, 3, and then to the right. And if I'm going too fast here, feel free to pause the video and either pull out graph paper. Here I just created this graph. You can find this on Google. You can find an image, something with a 10 by 10 or -10 to 10, +10 for both the x and y axes is a good range to work with. So we're gonna do a check again. It looks like it hits the x-axis at x equals 1. So I'm going to plug x equals 1 here. Again, -3 times 1 is -3. -3 plus 3 is equal to 0. So that's where it would cross. So that's consistent. Okay, great. Hopefully you're getting the hang of this. We got one more problem to go through. This last problem is y equals 1/4 x plus 2. So we're going to go through the same process again. We'll identify that our y-intercept is equal to 2. We'll plot this point on the y-axis at 2. And we have a slope of 1/4. So this is positive a positive 1/4, so it's going to have a positive slope. So we're going to go up 1 and to the right 4. So up 1, then 1, 2, 3, 4. And then we'll do it one more time. Up 1, 1, 2, 3, 4. And then we go down 1, and then to the left 4. So down 1 is a negative delta y, and then to the left is a negative delta x. So the signs will cancel and we get a positive 1/4. So down 1, and then to the left 4. 1, 2, 3, 4. Down 1, and then 1, 2, 3, 4. All right, and then we'll connect these dots. And then here we have it crossing the x-axis at x equals -8. So if you plug -8 for x here, we get 1/4 times -8, which gives us -2. -2 plus 2 gives us a y value of equals 0. So that is where we'll cross the x-axis. So great. Try a couple other problems. I'll put a couple other example equations that might look nice like this. You can always use an online calculator to verify afterwards to make sure that you are getting the same graph as you would expect. Remember, a good way to check is look at where it crosses the x-axis. And then also a good way to check is, are you following the positive or negative slope as expected? And are you crossing the y-axis as expected?